So let's start the communication and networking track. So myself, I'm Dr. Namal Karunaratna from Department of Computer Engineering, University of Peradeniya, and my colleague Dr. Upul Jayasinghe, Department of Computer Engineering, University of Peradeniya. So we'll be sharing the session. First of all, I let me introduce our invited guest, Mr. Anuradha. First of all, I'll give you a short introduction of himself. Mr. Anuradha is an expert in the field of telecom and technology, and currently working as a senior engineer at Sri Lanka Telecom. He has 2 decades of industry experience in strategy, architecture, engineering design, planning, and implementation and R&D. He is actively involved in strategy formation of his company, digital transformation, softwareization, and 5G. He is multi-award winning MEF subject matter expert for SD-WAN. He is also MEF SD-WAN certified professional. He also worked as a visiting industrial fellow at University of Hertfordshire and currently working as a guest lecturer at the University of Peradeniya and as a faculty at CTO UK. He is a senior member of IEEE, a fellow of IET, a fellow of BCS, and a member of ISOC. I kindly invite Mr. Anuradha. It's your floor. Thank you.
So I'm going to share with you some of my thoughts on the role of artificial intelligence. The role of artificial intelligence in telco softwareization. So I'm not going to introduce what artificial intelligence is. I think you have heard enough for the course of this conference. But I will probably introduce you to this word of softwareization. But before we start, if you really look at what the industry trendsetters or the industry analysts predict for the top technologies trends for 2023, we are halfway through the year. But just want to check this where they put applied artificial intelligence at the top, and also generative AI at number 3, something like that. So it's not just artificial intelligence, but the application of artificial intelligence is the prime importance for the industry today and also going forward. And the word softwareization actually comes from the people or the organization who first coined the term is this study group within IEEE, Software Defined Networks, where they say that the combined effect of SDN, Software Defined Networking, NFV, Network Functions Virtualization, and cloud can be referred to as softwareization or ITization. So it's more of a verb of combined effect. So what it really means, if you really try to look at these three terms, the first one is SDN, which is also referred to as sometimes as network softwareization, which talks about the decoupling between the control and forwarding planes. Those who have done networking, I think you have some sort of idea what the control plane and the data plane is. So it really brings the flexibility in forwarding in terms of networking. And if you really look at network functions virtualization, it's also sometimes referred to as network virtualization. Talks about the decoupling between the functionality from the location, which brings flexibility in processing. And the cloud, which is very much coming from the IT side of affairs, which is kind of alien to networking in the early days, talks about the decouple of infrastructure from the applications and brings in the flexibility in computing. So softwareization is the combined effect of all these three based on the classical definition. Although it's not a classical definition as such, the definition that came through IEEE, which is SDN NFV plus cloud. So that's softwareization in general. But if you really look at what telco softwareization, the telco industry, where I represent SLT Mobitel, we take the term a bit further and understand it in a more generalized way. It's not just the networking part or the cloud part or the network virtualization part. It's actually applying software to the conventional telco business and also the practices to the entire stack from the physical communication up to the applications. So it's going beyond the traditional understanding of softwareization. So as an industry, we are going through, as operators, service providers, etc., we are going through a transformation from where we try to become, different people use different words. For example, some say we are going to become from communication service provider to digital service provider. Some say we are trying to become from telco to techco, or service provider to experience provider. Those are more or less marketing terms, I would say, just to talk about the same thing in different contexts. But the umbrella term is actually telco digital transformation, which actually drives telco softwareization and also the cloud native transformation for telcos. So in this, if you really take it at very high level, it talks about the traditional viewpoint, the challenging the traditional viewpoint, what we refer to as networks, but really look at those as platforms in the full stack. And then if you think about the traditional building blocks of traditional networks, which is hardware network elements, and the focus is now shifting from hardware to software, and then moving from software to cloud native type of technologies. And if you drill down to the underlying technologies of these conceptual changes or the mindset changes happening above, I think NGN is something familiar to us, which came in early 2000s or late 90s, 1990s. And before that, we had something called old generation networks. Just to understand NGN better, that means something before that. And then moving to software generation network, nothing but the virtualization of the same NGN network, meaning that we're not going to challenge any of the communication protocols like how IP communicates, how Ethernet communicates, or any other data link layer protocols communicate, but trying to virtualize the network, and that is referred to as software generation network. And this also driving us towards to something referred to as telco cloud, even today and maybe in the future. And if you really look at the real technologies involved in these transformations, we had networks built on time division multiplexing technologies. And even before that, we had frequency division multiplexing technologies. And then we moved to packet, IP predominantly, and Ethernet, and then softwareization, and also then moving forward, cloudification. So if you take AI at very high level, the use cases for network and service management, we saw the application of AI in different other verticals, multiple industries in previous sessions. But this is specifically for network and service management. It is basically for a business purpose that we bring in AI to the telco field. I think it's quite different, the approach that you have, basically the academic approach of AI versus the industry approach of AI, especially in the telco domain. We are looking at numbers, for example, operational benefits, capital benefits, and revenue savings, energy savings, etc. And that is, some of them are here. So based on the numbers, we make our bets and investments on artificial intelligence in the telco field. Now, this is basically how it actually looks like when it comes to the full stack of the modern day telco operations. At the top, you have portals. For example, at the very top, you see portals where maybe as customers, you might engage with. For example, you log in and request a service, for example. And then you have support systems in the IT side of telco stack, OSS, BSS, operation support, business support, service orchestration, etc. And then you have element management, end-to-end orchestration, network orchestration, software-defined controllers, other controllers, VNFs, VNF managers, etc. And at the very bottom, your forwarding plane plus your computing resources, which is NFVI, Network Functions Virtualization Infrastructure, which is your data center. So if you really take it in a nutshell, basically we have two things. We have transport, which is your software-defined network, and we have storage and processing, which is your data centers now implemented using NFVI Mano architecture of HC. Now, what we try to do with AI is that we're trying to bring in AI capabilities to all of these layers. Like you can define layers in multiple ways, but I'll try to bring in, for example, AI at the customer interaction. How can we use AI for customer interaction? And that is the pretty easiest to involve with AI, and that is what most of the telcos doing these days. And then use AI at operation support and business support system, which is our internal IT operations to make things efficient, effective, maybe productive at internal operations. Then end-to-end orchestration at network level, at service level, and also possibly at forwarding and data storage and data processing level. So you can bring in AI at any level, and there's no hard and fast rule at which point, at which level you should bring AI, but these are all possibilities. And if you really look at the vision of autonomous network, or the self-sustaining or self-healing, self-managed type of networks, you can see that the drive is actually coming from, in my previous slide, it is actually coming from top to bottom, where rather than trying to bring in AI in the forwarding plane, how packets are forwarded and how things are actually processed and stored in data centers, we are trying to start with the easiest, which is actually the services, the end services that we offer to our end customers. And then try to bring in to our own operations, AI ops, and also then to bring AI to the network side. So you probably have heard these things like zero-touch networks, that you don't touch the network anymore. The network has the capability and the intelligence to sort of self-sustain the problems that will come. The network has the capability to do it on its own. And zero trouble, that is from the customer's perspective. And probably things like zero wait type of things. So everything zero. It's very easy to sort of explain that in a PowerPoint presentation, but it's very difficult to realize in a practical telco environment. And if you look at the AI capabilities embedded in at least one function or business unit 2022, this is based on research from McKinsey, you can see high-tech and telecom, they actually put high-tech companies and telecom companies together for some reason. And you can see the application of, for example, deep learning, neural network, natural language things, and robotic process automation, and virtual agents. These are some of the areas that the telco field is now doing compared to the other industries. So you can see all these applications are currently not on that stack in the network level, or maybe not the orchestration control or service orchestration level. So these are more towards the application or the service interaction, customer side interactions, and maybe a little bit of internal process improvements. And as telcos try to become like techcos or experience providers or digital service providers or whatever the name that you put, it actually try to sort of introduce more like an IT type of company organization architecture for telcos. Telcos, like, for example, if you take Sri Lanka Telecom, we currently go as SLT Mobitel, we have a history of 165 years. So it's very difficult for a company having a history of 165 years coming from multiple generations to sort of like magic become an IT company. So people are not used to think in that sense. So we usually think the network as hardware boxes, and we need to configure hardware boxes. So that is the natural thinking that we have. So it's very difficult to operate that type of a telco organization as an IT company, although the requirement to become a digital service provider or a techco is more demanding for us to behave like a one. And in an IT type of environment, those who have done IT project management, etc., you know that we have different models, for example, waterfall model, and then we have CI/CD models, agile project management models, DevOps, DevSecOps, DevNetSecOps, all these things. But currently, according to TM Forum, we are driving to something called as AI Ops. So that means that all the operations can be sort of bundled together with the capabilities of AI. And if you look at the intent-based automation, something like ChatGPT for telcos, like you ask a question and automatically things happen, and you give the intention to whatever the IT system, and that intention can be communicated down to the network level or down to the data center level, and automatically your intention is translated to the network language, and the network tries to become sort of based on your intention, reconfigure, pre-configure, self-adjust, all these things. So we have, in autonomous network, we have owners and handlers, and provide with you different capabilities going forward. So it's decoupling the what from the how. So you really don't tell the network or the system how to do it, but you really give your intention, what you want as a user, and then that using artificial intelligence capabilities will be translated how to do it. And this can be applied at different levels. For example, at the very bottom, you have your network resources. You can have resource closed loop type of automation. Then you can go one level above. You can talk about service level or service closed loop automation. And then you can even go further to look at business closed loop automation, and really to give the end service or the end customer the perspective of the improvements, the end user experience. You can talk about user closed loop automation. So the intent is actually coming from maybe the person who actually initiates the intention could be the end customer, right? Or maybe on behalf of the end customer could be one of our frontline operators. So that's the business intent. the business intent is transformed to the service intent, and the service intent is transformed to network intent or the resource intent. So at all these levels, artificial intelligence is actually used and also can be used. So what drives us, not just telecom networks, but let's say campus networks, enterprise networks, WAN, LAN, all other networks, is actually to eliminate the times where humans actually work with the networks and also try to do things, but rather try to make a system. When I use the word system, it's a very generic term, but no human intervention or no human involvement, where we use as level 5 in this categorization. Both ITU and TM Forum categorize this in these 6 levels from level 0 to level 5. We say the full intelligent network is fully run by the system. So you don't need people. Of course, you need people to draw wires and erect poles, but other than that, for general network operations, you don't need people. And this is actually a reality because China Mobile, one of the largest mobile operators in the world, they try to achieve level 4 automation by another 2 years. So that is the level, because if you take a company like China Mobile, which is the largest mobile operator in the world, obviously it makes sense, because when you are serving like potentially 1.3 billion subscriber base in China, maybe they are now serving half of that. It really makes sense to automate that type of network, because nobody is going to manage that type of scale, vast technologies when you are running at least a couple of generations of mobile technologies like 4G, 3G, 4G and 5G, maybe 6G in the future. So if you really look at the timelines, as I told you, the current timeline is actually looking at the easy stuff of artificial intelligence, I would say, like analyzing customer data, predicting something and proposing something to the customer, churn prediction, things like that. But what we are heading in the long term actually to towards autonomous networking and try to do it, I would say, real artificial intelligence in telecom networks. So this is more like, although you can call it telecom artificial intelligence, it's more like IT type of artificial intelligence, whereas that one is more like network type of artificial intelligence. So that will take maybe another 3-4 years in general, but the timelines for Sri Lanka, I think we need to really calculate that. And how would one evaluate your level of maturity in artificial intelligence? So TM Forum is one organization where we are also a member, is actually at very high business level. They propose different maturity model checks for an organization to self-check their digital maturity, their artificial intelligence maturity, etc. So this is one model. Obvious you cannot read it, but just wanted to make sure that you get the idea that TM Forum has artificial intelligence readiness check, industry accepted way of evaluating yourself as to how you progress in your artificial intelligence journey. And these are some of the standards from ITU-T, which is the sort of godfather for telecom standards for the last 165 years. And these are some of the standards like all these Y.dot standards, which is coming from next generation networking, and also J.dot and L.dot standards for different applications of artificial intelligence in telecom space. And 3GPP Release 18, which will be coming soon for 5G, is also looking at multiple areas in the entire 5G network, starting from the user element in the RAN and the core network and operation and maintenance practices. They're trying to bring in artificial intelligence, and there are all these system aspect study groups which are now working on. And also another thing is how to reduce the power, the energy. So that is also discussed in the morning, which is very much a concern these days. Power is pretty expensive. I got an SMS from Ceylon Electricity Board today. My last month electricity bill was something like 9,000 rupees, but this month it is 11,000 rupees. So it's pretty high for even for a household. But imagine a telco operators who are running all these things with power, unless you use reliable, sustainable, renewable technologies for power, it's pretty hard. So that is another area that we can use AI for all these practical issues. And so that is more on the network side. This is more on the network side, and this is also from the network side. So the bottom of the stack, or what we saw earlier. But then if you go above the stack, I would say those are the easy ones. Like anybody can come up of a software project these days. So this is the cloud native landscape. We are also involved in most of these projects. So these are up in the stack, the software level. So open source projects, see the amount of funding they get, over $50 billion US funding for all these projects. I don't think we get that much of funding for the lower layer artificial intelligence type of work. And then Linux Foundation has a separate committee or the community for artificial intelligence and data foundation things. So their landscape, which is also having budgets or funding over $20 billion US, and also market capitalization of US dollars 13 trillion. So that is the level of importance that the whole ecosystem has on artificial intelligence and data. And especially most of these projects are now used by telcos. So when you go to this level, up to the software level of the stack, anybody can use these tools. So let's say these are the canvas of tools. These can be used not just by telcos. For example, if you take, for example, Hadoop or something like that, it's not just for telcos. So Hadoop can be used by anybody. Let's say Kubernetes. Kubernetes is not just for telcos, anybody can use. So most of these projects are used by everybody. And definitely we also use these projects, because when you go up in the stack, we don't have any other choice. Us becoming an IT company means that we have to deal with these things. So the future is this, even for a telco, even for a healthcare company, even for education. So you don't really have any excuses, because when you go to software is this. So cloud native and all these things. So in summary, global AI landscape is promising despite challenges. Of course, there are challenges. And the real drivers of telco digital transformation is actually improve customer experience. So customer experience is number one for us, reduce costs, and also shorten time for new revenues. Telco softwareization is a key enabler of telco digital transformation, and it's going beyond the conventional concept of telco softwareization. It's combination of many other things other than SDN, NFV, and cloud. So AI can be introduced at multiple levels of the softwareized telco stack. So that is the important thing. So we are talking about a stack which is going from hardware to software. And in that stack, you can bring in AI at any level you want. And the easiest is the customer service, customer facing type of services, then the operations, and then the intent-based autonomous network, which is, I would say, compared to the others, the hardest, because you are really dealing with the network as such. Telco as an industry has the highest AI adoption. That's what we see from the analysts. And standards and the standardizations is very important. If you really don't have standards in this space, especially when you go down the stack, up in the stack in software, this is more like open source these days. Most of these things are open source. But if you go down for the real data communication, that is why the telecom industry survived for 165 years. We have strong standards for interoperability and all of that. So we really need to have those type of standards preserved at that level as well. And finally, since I think the universities and the academics also join, we have a huge skills gap in this space. So we are looking at people like new breed of species like network engineers, not software engineers, but network engineers, and people like computation engineers, not communication engineers, not computer engineers, but the people who understand communication and computing, people who understand network and software. So we really need these people to take this industry forward and to realize the objectives that I mentioned earlier. So that's all I have. Thank you very much.
Thank you, Mr. Anuradha. Do we have any question from the audience?
Yes, please.
You mentioned trying to attract that talent in a completely new discipline, multidisciplinary area. How are you actually approaching that? Are you getting interns? Are you looking for university graduates? Are you growing them yourselves? Are you finding that those skills are available in the market?
So one thing we do internally is we have our own research and development unit called the Embryo. That is the Embryo, where we have working MOUs with most of the state universities and also the private universities and also the other institutions, both local and abroad, because we understand it's very important to have all these ecosystem partners, without which it's very difficult to realize these goals. And one challenge we have is that most of the good people are now leaving the country, right? So what we think is that going forward, we really don't want them to be here. As long as they are living somewhere on planet Earth, I think this type of environment enables them to contribute even from those places. So that is a model that we are working. Maybe they go and work for Google, but maybe they can contribute like 2 hours, maybe 4 hours per week for our things, and maybe we can make them a payment as well. So those are some of practical approaches that we work on to address both. No problem.
One more question, Mr. Anuradha. So you mentioned about AI distribution or implementing AI in all the layers of the stack, right? So how challenging is it to implement AI in the bottom of the stack, physical layer? So, and how you are open for that as a telco company? How much you are open for that as a company?
I would say in 2 levels. Like if you ask me as an SLT Mobitel employee, we are not yet there. We are like the global trend is also to start from top to bottom, because from easiest to the hardest. So usually what we take is the approach of wait and see, because any new technology, I think it's one thought of ideas is that to embrace it from the very inception. Or the second thought, which is more applicable for countries like Sri Lanka, is to wait and see at least 3 years how the other markets actually use that, and then see the challenges, the solutions, all of that, and then adopt that. So it's not easy. We are still in the level of understanding how to use that in the bottom level. So one challenge I would say is the skills, lack of skills, and also the lack of standardization. So standardization at the network level, artificial intelligence integration is not that mature these days, but going above, it's not really about standards. Nobody talks about software standards these days. It's open source and open source community, and really boils down to the level of expertise you have internally. If you really have a very capable team, like, for example, Rakuten or Rakuten Symphony in Japan, they took the liberty to ask Nokia to just supply me the radio elements. Everything else, software, I can do myself. So if you can actually bring your team to a level of that, I think integrating AI, even at that level, provided the standards are ready, it's not going to be a problem. I hope I answered your question. Thanks.
But still the layered architecture is very strict, and the protocols and the network godfathers are very much strict about breaking the layer barriers. So do you think that it would be possible in the future?
By layers, did you mean the forwarding control, all of that?
Yes, and also this 5 layers or 3 layers architectures in the.
That's what I mentioned. Like when moving from NGN to software generation network, we're actually not challenging any of these standards. Like we are not challenging the TCP/IP stack, for example. We don't say that we are going to propose a new layer 3 networking protocol. No, we are going to use IP, we are going to use Ethernet, and we are going to respect and use the full TCP/IP stack. But because if you try to challenge that, I mean that's not going to work.
Yeah.
Somebody will challenge that going forward, but we are trying to use the basic communication stuff as it is, and then try to bring in all these capabilities around that.
Maybe that may be the reason that you said that there is lack of skills in networking.
Yes, yes.
Especially when you go further down in the stack or layer.
Yes.
Okay, all right. Thank you.
Any more questions?
Thank you for the talk, Mr. Anuradha. I had this one question that when you discuss about the AI readiness, you were briefly touching on that. How much involved the people are in that? I mean,
Not, yeah, that's a very good question. Not just for AI, but for everything that we do, not just in telecommunication space, but in other spaces. We traditionally talk about three things: technology, process, and people. I think people come at the very top. Without people, you cannot, I mean, even prepare the PowerPoint slides, you need people, right? So people is number one, but unfortunately, people are like, they're human beings, right? So they take decisions sometimes to leave the country, or sometimes maybe in the future go to the moon, for example. But keeping people in a team and to drive them to a common goal like this is harder than the technology itself. So it's a challenge, but it's a challenge that we all have to accept and try to find solutions together. I think we need your help, you need our help. So this is a collaborative effort that we all need to work together to find solutions.
yeah, thank you for that. Yes.
Are you finding that the national research and education networks are growing the sort of people that you need to hire that have these multidisciplinary skills? Or are you going more to the university market and looking for kind of younger people?
I think I don't differentiate between, I mean, I don't think age is a matter here, as long as you have the drive and the passion and you have the right, because you cannot underestimate the efforts. For example, a small open source community who's actually coming out a novel idea. Maybe they're not coming from the university side, they're not associated to a network like Learn, or maybe they're an isolated team. But as long as the idea can be used, I think that's the level of partnerships and collaboration we need to look at. But it's easy to say it, but onboarding such an ecosystem to the large ecosystem is challenging, because you're talking about like 5-6 people coming out with a novel idea, but who's going to sustain it? Who's going to support it? So if people like Learn and the universities and organizations like SLT Mobitel, the larger ones, can actually support them and bring the ecosystem and sort of underlying work as the underlying foundation pillars to make sure that the ecosystem is sustainable, I think then we can broaden it up, bring more people in, as long as we can make sure that the whole foundation is strong and rigid.
Yeah, Mr. Anuradha. And we highly appreciate your presence here all the way from Kandy to Colombo. Thanks a lot. Next, we will move into our paper presentations. Before I proceed, let me first give you the guide for the presentations. Each presentation allocated 15 minutes and 10 minutes for the presentation and 5 minutes for the Q&A. So to invite the presenters, I invite Dr. Upul Jaisingh.
Thank you. For the day, we have 4 presentations scheduled, and out of that, the first 3 are scheduled online, right? So we will play the video, and the presenters join online, so you can ask the question from them after the video. So we will start with the presentation, that is control plan comparison of Open Daylight and Open Network operating system controllers by Authors Mohammad Sati, Mohammad Emilit, Ahmad Machouk, and Salim Omar Sati. So can you play the video, please?
Hello everyone, I am Mohammed Sati from Misrata University. I would like to thank the organizers of this conference for discussing our paper, which titled Control Plane Comparison of ODL and ONOS. The authors are Mohammed Sati, Muad Mshihit, Ahmed Al-Maj'ouk, and Salim Sati. The agenda of this presentation will include an introduction for SDN networks. After that, the SDN control plane will be discussed. Then, SDN Java controllers that we have chosen for the evaluation, and then the evaluation topology. Also, we will mention the performance metrics that we have used for evaluation, and after that, we will discuss the configuration and results. Finally, I will give you the conclusion and future work. SDN, or Software Defined Networks, is a technique for providing centralized management and monitoring of large-scale networks. The SDN depends on a core component called SDN controller. In controller plane, the switches can communicate with SDN controller via two methods. The first one is in-band. This type of controller plane shares the open flow control messages with the user data at the data plane. The second one, which is out of band, it creates a specific controller channel between the controller and every switch in the topology, which leads to full separation and extra links needed to build this controller plane. There's various types of SDN controllers based on their programming language. For example, NOx is programmed by C++. POX and RYU are programmed with Python. Meanwhile, Floodlight and ODL and ONOS are programmed by Java. The programming language and its compilation technique can affect the performance. And because of this, we chose ODL and ONOS as Java controllers. ODL, or Open Daylight, is an open source Java controller, and it's considered as one of most popular SDN controllers that have large community support. It's hosted by Linux Foundry with membership of more than 40 companies like IBM and Cisco. ONOS, or Open Networking Operating System, is a collaborative Java project to help service providers to have centralized management and improve their network performance. It also can work as a distributed system to get more computing power, and it provides a simple web interface to manage the controller. For emulating SDN network, we used Mininet emulator, which is a Linux SDN emulator that used OpenFlow as a communication protocol, and it also supports different types of links and also topologies. The topology for the evaluation will be scalability topology with different number of switches. We used this topology specifically to show the effect of scalability on the controller plane. And also the paper focuses on the dedicated out-of-band controllers. That's why there is no data links between switches and controller. The performance metrics in our research are two. The first one is TDT, or Topology Discovery Time, which is the time consumed by the controller to detect all switches in the scalability topology. And the evaluation of this metric will be done with a REST API client. The second one is NOM, or Number of Overhead Messages, which is the amount of the control plane messages which is sent between the controller and virtual switches. And the evaluation tool for this metric will be Wireshark for counting and monitoring. This slide shows the simulation configuration of Mininet emulator, where we used scalability topology with different number of switches, based on the out-of-bound controller plane for both controllers, which they are ODL version 0.8.4 and ONOS version 1.12. For NOM, as the figure shows, we changed the number of switches from 10 to 70, and we collected the number of control messages using Wireshark tool at the same time for both controllers. We considered OpenFlow messages such as hello and feature request and feature replay. All these messages generated between controller and switches in dedicated channel based on out-of-band control plane. And we chose the scalability topology without connecting between switches to guarantee that we collect the only control messages without any impact of data plane for SDN architecture. As we see from the figure, when the topology size is 20 switches, the ODL generates 800 messages and ONOS generates 200 messages. And when we increase the size of topology to 70, the ODL and ONOS generates 4,600 and 2,300 control messages respectively. From the figure, the results of the simulation shows that ONOS has lower overhead with different sizes based on number of switches. And we can see that the difference ratio increases as we increase the number of switches. For TDT, we have used REST API client to communicate with northbound API for both controllers. And as we mentioned before, the TDT metric is time spent from controller to detect all switches of the topology. For testing topology, we changed the number of switches from 10 to 70. As we see from the figure, when the topology size is 20 switches, the ODL takes 600 milliseconds to discover the topology, and ONOS takes 400 milliseconds. When we increased the size of the topology to 70 switches, the ODL and ONOS take 4,600 milliseconds and 3,800 milliseconds respectively. In TDT metric, ONOS has lower discover time comparing with ODL. So as a conclusion, we can say that this paper compares between ONOS and ODL in terms of TDT and NOM performance metrics. Also, the results shows that ONOS outperforms ODL in TDT and NOM. For future work, we will evaluate more Java controllers like Floodlight controller, and also we will investigate other metrics. And here we have reached to the end of our presentation. Thank you for listening. Any question if there's?
Thank you, Mr. Mohammed. Can you hear us?
Yes. Hello.
Yeah. The floor is open for questions. Any questions?
Thank you for your presentation. What's the end goal that you're looking at? Is it to reduce the number of messages and increase the time or decrease the time for configuration? Or are you just looking at different protocols as an exercise in evaluating their optimal ability or performance?
The goal of our research is to make a benchmark or a comparison between controllers that they are programmed with the same language. So we choose Java controllers and compare between them as benchmarking of their performance. That's the goal. Okay, thank you.
Let me ask just one question. Can you hear?
Yes, sir.
Right. You're talking about inbound and outbound communication. So in this case, what we have looked at and how it's going to improve the performance.
I didn't hear the question. Please, can you repeat?
So in this inbound and outbound communication, which one you have evaluated, and what is your ground assumption? Is it clear? Hello?
Yes, sir. We have used outbound scenario. So
Outbound.
every switch have a dedicated channel with the control.
Okay, thank you.
Thank you, Mr. Mohammed. One comment from our side. So I think you need to, in your results slide, the text is too small to see. Maybe our audience couldn't see the some of the text. So maybe next time you better look into that as well. So anyway, thank you very much for sharing your results, the work with us. Thank you, Mr. Mohammed.
Thank you, sir.
Our next presentation is open source soft processor side channel analysis attack framework using RISC-V. So I invite, so the authors are Mr. Darshan Jaisingh and Sri Parameswaran. Can you play the video, please?
Good afternoon, everybody. I'm Darshana Jaisingh. Welcome to my presentation, RISC Open Source Soft Processor Side Channel Analysis Attack Framework using RISC-V. This is the overview of my presentation. The power dissipation of a cryptographic circuit does depend on the data being processed. We often use oscilloscopes or high-speed analog to digital converters to measure power consumption. As an example, let's take a register and it can hold 0 or 1. If we load a new value, the old value will get updated. So there are 4 combinations or transitions for that 1-bit register. They are 0 to 0 transition, 0 to 1, 1 to 0, and 1 to 1. The power consumption for these 4 transitions are not equal. As an example, 0 to 1 and 1 to 0 transition takes much higher power. Therefore, by modeling the power consumption of a circuit based on input or output, the secret information being processed in that circuit can be extracted. In order to do the power modeling, we either count the number of ones of the intermediate values, to which we refer to as Hamming weight, or we use Hamming distance, where we count 0 to 1 or 1 to 0 transitions. Because from this graph, we know that the 0 to 1 and 1 to 0 transitions takes extra power. Similarly, we can use electromagnetic radiations, and the EM leakage is often treated as a side channel leakage which is proportional to the power consumption. However, the EM leakages can be measured from a specific location of the FPGA or on the chip. Similarly, we also can use timing side channel information to reveal secret information. For example, I have taken this code from GCC string layers to strings. So the string, or in this algorithm, the strings are compared until a mismatch is found. Therefore, by measuring the time using a high-speed stopwatch or a clock cycle counter, we can brute force the original string. Soft processors are implemented on FPGAs or field programmable gate arrays and have the ability to change its design based on user requirements. Often, the soft processor is connected to other hardware components such as input-output devices or memory via an interconnect or a bus line to build the soft processor system. The memory can be either on-chip or off-chip. And there is also a clock source to execute the soft processor system. And there are proprietary soft processor systems as well as open source soft processor system. The low risk soft processor system is becoming more popular due to their RISC-V instruction set architecture, and low risk has a rocket chip soft processor core which is implemented by the University of Berkeley, and it uses an open source bus called Nasty Bus for the communication. We took the RISC-V core and implemented and connected a nasty interconnect which has 8 channels, and each channel can be connected to an individual hardware component which can be uniquely addressable. We have added a serial port to communicate via the PC, SPI hardware module to load an operating system via an SD card, GPIO connection, and also custom hardware modules. These hardware modules can be used to implement accelerators or dedicated cryptographic circuits or even performance counter. The RISC-V core can communicate with these custom hardware modules and get the data or data being processed by these custom hardware modules. We implemented RISC setup on a commercially available side channel analysis attack board referred to as Sasebo board, and it has a Kintex 7 FPGA. The main soft processor system is running on Kintex 7 FPGA, and the soft processor system takes around 22% of FPGA resources, and the free resources can be used to implement the circuits or the design to test side channel analysis attacks and countermeasures. And this is the FPGA board and the Kintex 7 FPGA. So we measure electromagnetic radiation using an EM probe, and we measure power dissipation, and then we enhance power dissipation via a signal amplifier. Then we fed it to an oscilloscope. So we used AES advanced encryption standard algorithm to test the side channel analysis attacks and countermeasures using RISC system. AES has a 128-bit key, and then the other research so that AES is vulnerable to power, EM, and timing attacks. And as a case study, we also implemented a small countermeasure, which is a balanced AES implementation, which aims to balance the power dissipation. Therefore, the data-dependent power consumptions are eliminated in AES design. AES takes few operations: sub byte, shift rows, mix columns, and add round key. Some operations are performed on hardware, and the rest is performed on the soft processor system. So first, we try to implement an AES sub byte operation as a table, and then AES operation as a dedicated circuit. And AES can also be implemented by combining sub byte and mixed column operation, which is referred to as T tables. So we also implemented a hardware version of T-table, and then finally balance S boxes with the original one and the inverter design to balance the power consumption. And we measured power and sys attack resistance and also EM attack resistance. And each attack is repeated 100 times. Therefore, we can calculate the success rate, which is directly proportional to the probability of revealing the complete secret key of AES. And there we found out that the AES T-table implementation, both software and hardware, reveals the secret key within 250 encryptions, and AES SBox circuit-based implementation takes much more traces, around 2,500 traces to reveal the secret key. On EM attacks, the software SBox implementation reveals the secret key within 3,000 encryptions, little bit higher than the PA attack. And the SBox hardware implementation needs more than 8,000 traces to reveal the complete secret key. The SBox circuit-based implementation revealed the secret key around 4,000 traces or 4,500 traces. We believed because we can measure the electromagnetic radiation, we were able to measure the electromagnetic radiation from the SBox circuit. Therefore, we were able to we could break AES circuit with less traces. And then we implemented a balanced hardware implementation, and then we measured the success rate of each key byte. And among 16 key bytes in AES, we found out that the software balanced AES version reveals around 14 key bytes, and the hardware balanced AES implementation reveals only 8 key bytes, which is much more resilient against power and attacks. We also tested timing attack vulnerabilities, and we found out that when we start AES, the number of clock cycles are varying, and then after few encryptions, the elapsed clock cycles remain constant. As the conclusion, this paper presented the first open source software systems where users can freely modify hardware components and then test side channel analysis attacks in FPGAs. And we also demonstrated like how software hardware co-design can be used as a countermeasure to provide enough security.
Thank you, Mr. Darshana. Any questions from the audience?
I'm really sorry for the quality of that video. It was my very first video presentation.
That was an absolutely fascinating presentation.
Oh, thank you.
How secure would you consider RISC-V to be as an architecture, and have you looked at other architectures in comparison?
Okay, so I work with microblaze and little bit of picoblaze. They all are vulnerable to side channel attacks. How many traces we need does depend on they all can be broken within 10,000 encryptions if we have right equipment and your signals are very clear. Advantage of RISC-V is you can actually integrate different countermeasures into software as a core compared to the proprietary ones. So I would say they all are vulnerable to side channel attacks.
Right. Thank you, Mr. Darshana. So you have tested the results security-wise and time-wise. So have you done any comparisons with groundwork or any benchmarking have you done it? So do you have any work to compare with?
Mm, no, in fact, so with RISC-V, there were few papers where they try to perform, try to implement a countermeasure. But with microblaze and stuff, I don't think there is much work done with respect to measuring side channel analysis attack resistance. So yeah, I would say no, there's not much work to be compared.
Sure. Any more questions from the audience? Since there are no more questions, we can wind up. Impressive presentation, Mr. Darshan. Thank you.
Thanks so much. Thank you.
Now, the third presentation, from opacity to clarity, leveraging XAI for robust network traffic classification. Authors are Chamala Sandeepa, Tulitha Seniviratna, Bart, sorry for that, Nguyen, and Win Hola, Shen Wang, and Professor Madhushankar Liyanage.
Sandeepa, and this is our presentation on the paper from opacity to clarity, leveraging XAI for robust network traffic classification. We are from University College Dublin. We had this research together with the Montemarch EURL. So just moving to the introduction first, identifying how resilient these AI models against several attacks is a critical steps that we need to address in order to achieve AI-driven future beyond 5G or 6G types of networks. For example, if you see an attack, if it is a successful one, then the models can either be stolen or taken under the control of an attacker, or it might get disabled. Therefore, it is essential for us to identify or at least mitigate certain types of attacks that can infer this consumer information or exposure of private use information, or reconstruct the original data using this training of the models, and deliberately make the predictions changed by changing the decision boundary, and also creating backdoors that can make incorrect outputs or critical decisions. So these are the main or major types of attacks that could impact on the AI models. So we name them as poisoning, evasion, backdoor, and inference types of attacks. So in this paper, we use an example of network activity classification for demonstrating attacks and their impact. So to create the use case, we first generate a network activity dataset. So for that, we use a sample user where the user is using internet or network and consume some activities in there, like watching videos or browsing the internet. So from that activities, these activities are captured, the packets are captured using this capturing device, which is the tool that we use called as Wireshark. And from Wireshark, we convert these files into CSV files using this tool called as MMT Pro. And this is an example converted CSV file that we could see. So from that, as the first step, we move into the next step, which is basically creating the machine learning models and launching attacks. So we have like two types of attack, which is the poisoning and the evasion attack. And the poisoning attack is done on the training phase, and the evasion attack is done at the testing phase. So first, the machine learning models are trained using the trained data set. And then we invoke poisoning attack and observe the resilience metrics before and after the attacks. So the resilience metrics are impact and the complexity. And we also observe the changes using XAI metrics. We do the same for the testing phase via an evasion attack. And we use the same type of metrics to observe the differences in the models. And the one that we have used for the user activities are the web browsing and interactive sessions like the video calls and video playbacks such as YouTube. And the source code is available in this link. So if you need more information on this, you can visit this link. And so these are the experiment setup information that we have used for our machine learning model training. So the data that was collected was 279 training and 103 test data with 22 features for each record. And we trained a neural network, and this model consists of 3 layers with 12, 8, and 3 dense units. And we used Adam optimizer for training these models with a batch size of 10, and we run for 150 iterations and reach a test accuracy of 96.12. And so these are the attacks at the training phase, which is the poisoning attack. So basically the poisoning means like we either mutate the existing data, that means like we modify the existing data, or else we can add new data, which is called as poison data into the model. So based on these two types, we have defined 3 poisoning attacks, which is the first one is the random label flipping, where we randomly change the labels of the original dataset. And the targeted label poisoning is basically the modifying labels only for a selected class, not all the random labels. And the third one is the GAN-based poisoning, which is we generate new poisoning data using generative adversarial networks, or GAN, and we inject this poison data into the model. So these are the metrics that we use to assess the poisoning attacks. So the first one is the impact, which is basically the variation of the model accuracy or the error with and without the attack. And the complexity is the variation of the model dataset amount with and without the attacks. So we can see that the impact with the GAN-based poisoning, or the new poison data here, the GAN-based poisoning is much less than the other two types of attacks. This is because the GAN-based poisoning is made using these generative adversarial networks, which is a good representation of the original dataset, so that the attack tend to hide within the benign dataset. So that it will be like much difficult to spot the impact of the attack. But if you consider the other two types of attacks, they are much easier to distinguish because they have a high impact. And if we see the complexity, it applies for the same, where the other two types of poisoning have higher complexity, but with GAN-based poisoning, it is significantly lesser. And we can observe the same type of behavior with explainable AI. We use SHAP values for obtaining these feature changes. So we can see like the GAN-based poisoning is quite similar to the no poisoning scenario. But if we see the random poisoning, the top features are much different than the other two graphs or the visualizations that we could observe. Then we move into the test phase attacks, which is the evasion attack. So we use the same type of metrics, but in the complexity, we use the total CPU time for measuring the complexity of the attack. And so similarly, we observe a significant impact with deviation attack for different types of machine learning models. So we can have the impact of around 29%, 28%, and 45% for these different models. And the complexity remains same for all the types of models. And if you see the XAI feature changes with deviation attack, we can clearly observe that there's a significant difference between the attack scenario as well compared with the benign model, where there's a much difference in the top features of the adversarial attack compared with the benign model. Therefore, if we summarize the findings, so we can observe that the differences in an attack-driven neural network model compared with the benign model. So for evasion attacks, the feature importance scores are much significant, and we can clearly observe the XAI feature changes. But for poisoning attacks, this is not trivial, because for label poisoning attacks, the XAI features show clear difference in XAI, as well as impact on the complexity. But for GAN-based poisoning, these changes are not that significant. However, for majority of these poisoning and evasion scenarios, we can see there's a potential detection mechanism that we can use with the explainable AI, which is basically the SHAP values. And therefore, we can easily use this technique to mitigate these types of attacks such that we can actually safeguard machine learning models from evasion or poisoning. So this is a summary of our contributions, and mainly XAI-based feature visualization and detection strategy is the novelty that we have contributed from this work. So if you have more questions, feel free to reach us, and thank you very much.
Thank you, Mr. Sandeep. Any questions from the audience? Okay, Sandeep, I have one question. So you have used a couple of hyperparameters, right, for your training the model. So what was the rationale behind choosing those parameters?
Yeah, so for this scenario, we have used like certain type of like only neural networks, for example, and in there we use a fixed set of layers. But that's basically to identify if there's any impact on the XAI for a fixed type of machine learning model, and keeping like some randomly selected architectural component. But in the upcoming experiments that we are performing right now, we are trying to change these hyperparameters and parameters and see how the impact of these parameters and hyperparameters would actually impact on the overall predictability of these models with the explainable AI, as well as the other classical type of metrics like impact or complexity.
Yes, I think you should try it.
Yeah.
Any more questions? Seems everyone got it clearly. Thank you, Sandeep, and
thank you very much.
Our last presentation for the day, turbocharging your workflow, unleashing the power of modern tools for developers, system admins, and network engineers by Mr. Alex Mora.
Oh, hello, good afternoon. Thank you for having my presentation. I'm Alex Moura from KAUST, the King Abdullah University of Science and Technology, and I am working there as assistant senior network engineer and science engagement. I do the connection between the IT division and research and scientific divisions there in the university. And I also work in partnership with network research and education networks and collaborating different projects. I don't bring anything very sophisticated as the previous presentations today, but I hope that any of this information I bring today will be useful in any level for you. My idea for this was that we take for granted the power we have in our computer devices today, mainly when we are talking about working in the terminal specifically. Nevertheless, we do a lot of our work on software development, network administration, and many other IT services and actions are done in terminals. And the terminal had a long journey since the beginning when the first computers and devices were controlled by those typewriters, teletypewriters or teletypes or teleprinter machines, and they were electromechanical devices, and they are completely obsolete today. But we have seen this journey of the evolution of how do we interact with the computers and using monitors, using keyboards and other devices for inputting and receiving the outputs. But today, terminals, they don't work as the old technology. Their purpose is still the same, and in the sense they read the text input we put in the device. We usually using a keyboard, and then we get the response. And then what we call today a console, typically in the old days was referring to a physical device connected to a screen or a keyboard to input the commands. Now we have this software running everything. So terminal console are essentially the same thing, and it's just another software running in our computers. And the shells do the most lifting when we are working on the terminals. And then they accept the commands and they process them and they give us the outputs. And we have a large number of options of shells to work today: bash, fish, Z shell, corn shell, C shell, TC shell, PowerShell, etc. In many different platforms we work. We can work on many different operating systems from old Unix, BSDs, the Berkeley Software Distribution Variations, the Linux operating systems in all distributions, and even the Windows operating system has its own terminal. And today we can see that there are many modern terminals in software in which we can have a much richer experience if we know how to explore that. And then we can customize and adapt things for better productivity work. We can select font faces, different sizes, color schemes, different themes, multiple tabs, windows, and in the available platforms, we have the Unix, the old Unix with running the X Windows system, running the Xterm as a terminal. In the Linux operating system, we have many different options of terminals in Windows and Macs. So there are many different variations and options. It's easy today to find a very good modern option, which are the things I try to bring here today to show you the many new software, new solutions that are very interesting and then can make life easier and more productive for professionals in general.
So today we have many features available. You can customize with different color schemes. In the days we have to work with those green layers on the black screen in old terminals in the first personal computers. In some cases, use different phosphorus color like amber monitors. Um, and if you're looking in the old days, you could use a color CRT, color monitor. But today we have all kinds of different options that we can customize, and that can be very productive in terms of the speed. How can you find the information on the screen? It's much easier to find certain bits of information if it's highlighted in different colors than if you see everything in the same color text. So you can customize your terminals using many kinds of options of themes today. And the modern shells bring us features like auto completion, auto correction, automatic change directory options, recursive path expansions. So it's much easier to type and having assistance of the system and the shell helping you to do your work. So today, almost everything is possible during just the terminal. You can watch even videos. Sorry, you can do almost everything with a few exceptions, which is watching videos and wonder which web pages are interactive pages in the web. But you can do a lot of things, including listen music, using a computer with a text terminal. As long as it has the audio system working, of course. But you can manage virtual machines. You can, thank you.
You can manage virtual machines, you can run containers, you can run all kinds of virtual environments for development, for network management, for simulations. You can have your own digital twins. And the beauty of using terminals and not graphical user interfaces is that it's much lighter for the devices. And then you can have multiple even virtual machines or containers running in very modest computers or devices today. And with those, we can manage services, systems, servers, and entire networks. And you can do a lot of work. You can code, you can read, you can send email, you can navigate the web with field limitations, listen to music, and do a lot of things. So I am bringing some of these new modern tools that are easily found for free on the internet, and you can download and you can use today. And hopefully it can increase your productivity using the terminal. So some of the good features that we can find today, besides the text highlighting with different colors, giving context to the information you are watching, you can customize prompts. You can see notifications. You can run scripts. You can use aliases and also regular expressions, typing on your terminal, and then it can make you work faster that way. And to use the coloring in the terminal, you can use a different shell themes or plugins that you can run, and then it gives you automatically off the box a better experience. Okay. And then you can benefit from all the modern options like, okay, and you can benefit of all the options and features I already commented. some other features that are available are the shortcuts in the keyboard that you can run with arrows or typing some letters and using the tab key to autocomplete or show you options which were not available in the previous in the past in previous systems, but those are available today in the modern terminals combined with the modern shells. For example, you can find a long path of folders and directories or subfolders, and you can just type parts of the information and use tab completion to reach that faster. You can verify that modern terminals can help you be productive, not making mistakes while typing. For example, you can see the first image on the top. The word is in red because it's not correct. It's not a complete correct command. And the second image in the middle, you see the color is green, showing you that you are typing the correct command you want to run. And then in the bottom image, you can see the command in one color, the parameters in another one, and the file path, directory, and file name in a different color. So, and another bit of information is that in the prompt, you can see also little images or icons. So this is a combination of a customized font that can be downloaded and used. And then the prompt is customized to show you the time and how long it took the command to be executed. So there are many different features that we can explore in the modern terminal that can make us more productive. And we can use tools like terminal multiplexers, which allow you to multiply your terminal options, even if you run on an old console, an old computer with just one screen. You can have multiple virtual terminals on that, and you can multiplex between them. You can attach, deattach, reattach. You can close a session. You can have multitasking. You can run multiple sessions or commands in different virtual terminals. And you can manage that using tools like Screen, which is a Node tool, or Tmux, which is also very old and from the 90s. But today we have a modern option, very interesting tool that brings us a modern approach to terminal multiplexers like Zelig. And it has floating panes, command panes, scroll back editing, has many features. And it's really nice to see the default for the tool already brings you a lot of options right in front of you. Meanwhile, the old options, the old tools, they were quite obscure. You had to read a lot of manuals and find the correct keystrokes to manage the screens and terminals. And then here you have easier and more intuitive way to work with the tabs, with the menus, with the options. You can have multiple panes. One screen can be arranged in different layouts, predefined layouts. You can use that for your development, for example. Or if you manage a network, you can have multiple devices and working on multiple devices at the same time if you need, like to see the result of your action in one device in another, for example. Another tool that's a new modern option to have is the APAN, which can replace the history of the commands you gave in the terminal. This tool is interesting because it places all the commands, the history of your commands into terminal in a database, and it can centralize all your sessions history, and you can have the same history of commands shared among many different sessions and even different computers. So you can recall old commands that were typed or long lines of commands that were typed. And if you don't recall exactly what were the parameters or the options you used, you can find it easily using the search function and then recall quickly what you have typed. So it works like a very fast search. So you can type what you want to find, and it goes back through the history and filter the past commands. And you can navigate and do a lot of different options there. Another interesting tool to bring us to a modern 21st century experience in the terminal is the GRC, a generic colorizer, which allows you to have colors in many of the old commands that we are used to run that were in a monochromatic font, for example. So we can use it for having highlights of bits of information from commands like the ping or trace route or for development. So it helps you to find more easily and read the information, I think in a more adequate fashion. I hope the colors are not distracting for everyone, but I like the colors to help me to be more productive to find the information I need. And you can run this, this tool can make the colors in many popular tools for network management, as well as for software development or system administration. You can see a colored output for a DNS request, a request for information from a domain in the internet. And you can see that's easier to find the TCP connections that are established in a computer connected to a network by looking at the last column where the word is in yellow. Another tool you can run today is the bat instead of the cat, which is an old way to print the contents of a file on your terminal. This tool works goes a step beyond cat because it can color code depending on the type of the source it is displaying. So you can see color coded for a Python script or C code or a Python code or any kind of different file, a YAML or a markup file like this in this screenshot. And it completes the information, show you a file, displaying the file name, numbering the lines. You can select the theme colors you want to see, the text, and you can show the output of multiple files at the same time. So there are many features in all of these tools that I'm showcasing here that can be explored and combined, as in the Unix world we always do. You can throw the output of a command to another command and another command, and piping one command in the other, and it can do a lot of things. You can have in the terminal a IP address calculator. It can be very useful for many purposes for many professionals, and it's easier to find the IP ranges, the network mask, and it's everything colored, so it's easier to read. I think that's very nice to have. You can check the weather. You can see that in Colombo, the temperature. You can just run a simple command in your terminal, and it doesn't. This isn't. This is not a tool per se because it's a website. Okay, I'm just finishing, and this is very useful. there is the FZF, which is a fuzzy finder. You can throw in a lot of text from different kind of information, like file names or history commands, and you can filter those look for what exactly you are looking for, typing the commands, and it can show you the options. You can manage virtual machines using different tools like the multipass or MarkPine or Lima and Colima in a terminal, and then you can have almost all kinds of operating systems available in this fashion in almost all kinds of computers, even your laptops. It's very lightweight. You can multiply your options to develop software or test new software or test components or manage networks or even create a network in a virtualized environment. These are options available in some platforms. Multipass is available in Linux, Windows, and Mac, and the other ones are limited to Mac or Linux. And if you need to run multiple Linux distributions, you can use DistroBox, which is very useful also for testing or for developing or any kind of use you have in a computer. So you don't have to keep reinstalling the OS in your computer if you want to try different distributions. And you can have a notification in the command line showing, for example, a notification in your cell phone using the tool called NTFI, which I think it's pronounced notify. And for the last tool that I bring you, it's a modern recent tool available is How-To, which is ChatGPT for the terminal. You can go to the website and download it. It's free, and it gives you 5 commands per day, 5 questions per day, and you can actually have very useful outputs from this tool, where you can ask, how can I check the disk partitions in my computer? And it can reply you with the correct command line you need to run to see the output you need. So these are a few bits of modern options that you can have in your day-to-day. I hope any of these tools can make your life easier and more productive. Thank you.
Right. Thank you, Mr. Alex. Do we have questions from the audience? Any question from the online members?
Mr. Alex, what's the novelty and the research outcome of your research? Is it a research or just a survey?
This was a survey because in a journey to network automation, we are developing a new set of methods to work with different tools, and some of these tools here are part of this process. We are going to develop a method to create digital twins, and then we need to automate using the virtual machines and every kind of tool that can automate actions. And we don't want to rely on graphical interfaces because we need everything to be scriptable. So we need to run everything in a scriptable way or language or program, and then we need to run those things in the terminal all the time. So that's why we need to find the best tools for the actions we need to perform, and when we are going to run our virtual laboratory for the digital twin of our campus network.
Thank you. Right. Thank you, Mr. Alex, for your informative session. Thank you.
Thank you.
Right. In this session, we have conducted one invited talk and 4 presentations. So next, it is the certificate distribution. So first of all, I will invite the last presenter, Mr. Alex, to get your present. your certificate. Thank you. So with that, we can wind up the session on communication networks. Thank you very much for your attendance in this session. Thanks.